In this video, we're going to be talking about how to divide radicals. So we talked about radical operations. And similar here, but a little different. So let's talk about this and how that works. So first, the steps. If you have two numbers under the radical called the radicands, you could break it apart into two separate radicals, the square root of a over the square root of b. That's what this part would be. And then if, depending on the numbers, look for perfect squares and then simplify them. Simplify them if they're not perfect squares. Divide and reduce the radicands if possible. Simplify whatever the resulting radical is along with any coefficient. So there's a bunch of different things that could happen. Any of these could happen. All of them could happen. It depends on the problem. Alright, so let's go through, I'm going to go through a few. Starting with number 1. So you could do a couple different things. Think about this like I could separate this into the square root of 49 over the square root of 100. Both of these are perfect squares, so that would give me 7 over 10, and that's it. And then anything with a perfect square would do the same. But if I had something like 8, well, these are both underneath the radical. So instead of separating them into two different radicands, I'm going to just simplify what I have. 8 over 32 does simplify to 1 over 4. And then I can still do what I did in number 1 and separate it. Because both of these are perfect squares, this would give me 1/2. Right, going on to number 3. So I know that I can't simplify this, so I'm going to try to break it apart, separate the radicands first. And I know I can't break apart the square root of 3, it's prime, but I do know the square root of 16 is a perfect square, which is 4. So the square root of 3 over 4 would be my final answer there. I'm going to skip 4. We're going to come back to that one. Number 5 is already broken apart. I cannot simplify the square root of 10 because the only factors are 1, 2, 5, and 10. And then nothing is a perfect square or something that can be broken down more. But I can simplify the square root of 45 to the square root of 9 and the square root of 5. And I know the square root of 9 is 3. And then I have that situation where I could, since both are underneath radicals, I could divide 10 over 5. This would kind of be like this. And then I get 2. And then I would just rewrite that again. So my final answer would be the square root of 2 over 3. And you can check any of these by putting this into the calculator. So let me pull that up really quickly. All right, so in my calculator, my problem was the square root of 10 over the square root of 45. And if I put that in, I get some decimal. It's okay that you got a decimal. You just need to make sure that whatever you get next is the same decimal. So if I put in the 2 over the square root of 3, the square root of 2 over 3. Okay. I got the same thing, so I know I did that right. I kind of went about this a longer way. You could have also just rewrote this as 10 over 45 and simplified that to divide both by 5, 2 ninths, and then separated that like that. and then the square root of 9 would have been 3, so you would have got the same thing. Either way, it's really your preference. Both methods are fine. All right, I'm going to skip 6, go on to 7. And I'm going to start by just dividing, rewriting it as 1 dividing. So 32. So now I no longer have a fraction at all, and I can just simplify this like normal. So I know 4 goes into 32, but so does 16. And the square root of 16 is 4. And again, if I were to put that in, and put in my 4 square root of 2, we get the same thing. So we're good. Alright, a few more of these, and then we're going to move on to a little bit more of a challenge. So number 8, I'm going to go ahead and divide 108 and 6. So 18. We have 7 times the square root of 18. And I know 9 and 2 go into that. And I know the square root of 9 is 3. So that would give me 21 times the square root of 2. I'm not going to double check every single one, but you definitely should to make sure that you're getting the right thing. Let's do 9 and 10, and then we'll move on. So for 9, again, you have different options. You could either simplify the 45 or divide it. I'm going to go ahead and divide it. So that would give me 1/9. And here, both 1 and 9 are perfect squares. Like this for now. So that will give me 3 times 1 over 3. And in this case, my answer is just 1. So I get a whole number. And if I were to put that in, 3 times the square root of 5 is actually the same as the square root of 45, which is why this ends up being 1. Alright, last one on this page. 4 and 3, my coefficients on the outside of the radical, cannot be simplified, but 15 over 27 can be. I'm going to rewrite this as like this. And then 15 over 27 would simplify to be 5/9. And then again, I'm going to go ahead and separate. So we have 4 times the square root of 5 over 3 times the square root of 9. The square root of 9 is just 3. So we have 4 times the square root of 5 over 3 times 3. So 4 times the square root of 5 all over 9 is that final answer. And when you start to get a lot of things like this, that would be a great time to double check yourself. Alright, now we're going to talk about something else. So all the ones we've had to do so far came out as a nice number, like there was a number at the bottom, it was easily simplified. Now we're going to talk about what happens if you end up with a radical in the denominator. So in general, we don't want that because it's not fully simplified. And then, in order to get rid of that, we're going to do something called rationalizing the denominator. So to do that, we're going to multiply both the numerator and the denominator by whatever the radical in the denominator is. And this works because the square root of, let's say, 4, actually let's pick something that's not perfect square. The square root of 5 over the square root of 5 would simplify to be 1, and I could double check that. So since our multiplication properties work here, we're allowed to do this. Alright, so I said I was going to go back and do number 4, and I'm going to do this 2 ways. I'm going to do it as taking the square root of both first. Whoa. And if you took the square root of both, so that's not what we usually do, we usually just divide it. But if we did this, we'd end up with the square root of 7 over 49 is a perfect square, so just 7. Final answer, done. However, if we had divided this would give us 1/7, and then I would break that apart. I know the square root of 1 is just 1, but then I get this radical in the denominator, and that's where things get iffy. This is where your rationalizing the denominator would come in. So what we're going to do is take that radical, multiply it in the denominator, and what we do to one piece of the fraction, have to do to the other, so we're going to multiply it again here. And then that becomes, I'm just going to write this down here, the square root of 7 over the square root of 7 times 7, since they're both underneath radicals. And we know that is the square root of 49. And then we're back to this step right here. And then we just take the square root of 49, which is 7, and gives us the square root of 7 over 7. So now let's do some more of these on this page. We're going to start with this 13. We can't divide them as is because 1 is not in the underneath the radical and 1 is. So we're going to rationalize the denominator, take that denominator, multiply it by the square root of 7 to the numerator and the denominator. And when you do this to the numerator, because it doesn't already have a radical, it's just, the fourth is going to become a coefficient. Once you get the hang of this, you can start skipping steps, but right now I'm just doing every step. So we have the square root of 49, which we know is just 7. Now, these two 7s would not simplify because 1 is in the radical and 1 is not. So that would be your final answer. Okay, I'm going to stick around. In 15, if I were to simplify that, well, it can't be simplified because 1's even, 1's odd. So I have to separate it. And then take the square root of both. So I know the square root of 81 is 9, which leaves me with the radical of 2 in the denominator. So I'm going to go ahead and rationalize that denominator, multiply it by the square root of 2. So we get 9, oops, sorry, my board is weird in spots. 9 times the square root of 2 all over the square root of 4, which would give me 9 times the square root of 2 over 2. That does not simplify, that would be my final answer. Right. Remember to pause, double check yours, pause and move on whenever you feel like you need to. Right. And then for 17, so here, if 3 and 2 could simplify, then we would do that, but it doesn't. So I'm going to have to rationalize, and I'm going to multiply. So I have 4 times the square root of, this would be the square root of 6 over the square root of 4. The square root of 6 can't be broken down further, so that's going to stay the same. But the square root of 4 does become 2, and I can divide 4 by 2. So this becomes 2 times the square root of 6. I haven't been checking them for these past ones, but I'll check it for this one. Oops, I just saw what I did. Okay, so there's our decimal for that, and then our answer, we have 2 times the square root of 6. And we got the same thing. Alright, just a few more, or actually just a couple more. I'm going to do 19 and then 22, and then you guys will have time to practice. and ask any questions you may have. So 19 is similar to 17 where, actually, let's do 20 instead of 19 because 19 would have been similar. So in 20, I can't simplify 2/5, but I can rationalize the denominator, and I'm just going to multiply the square root of 6 to both. So I know the square root of 36 is 6. So I have 2 times the square root of 6 over 5 times 6. So I have 2 times the square root of 6 over 30, which would simplify to be the square root of 6 over 15. If you wanted to, you could have also multiplied by 5, like the whole thing, 5 times the square root of 6 to both the numerator and the denominator, but then you would have to simplify it a lot more because you would be changing the number in the numerator and then would have to divide it and simplify it. Sorry, the bell. And then 22. So here, similar, I'm going to just multiply everything by the square root of 6, or both pieces by the square root of 6. I can't simplify anything. Oh, actually, I could. So let me backtrack. I could simplify 3 over 6. And then just go from there. So I have 2 times the square root of 1 over square root of 2, which would give me 2 times 1 over 3 times the square root of 2, and then I could just rationalize that. So we have 2 times the square root of 2 over 3 times the square root of 4. And the square root of 4 is just 2. So we have 2 times the square root of 2 over 6, which would simplify to be the square root of 2 over 3. You could have also did it how I was going to start it, multiplying everything by the square root of 6, and then went from there. Either way would work. Now you have a chance to practice, try this on your own, come see me with any questions you may have.